Hi guys, my name is Ian and today I will talk about a technique called sliding window, which is used very frequently in both technical interviews as well as competitive programming. So what is sliding window technique? Before I walk you through how that works, let's see an example right here. Given a subarray of size n, there's n elements in here. My problem that I present to you is, can you find the largest sum of a contiguous subarray of size k? For example, starting at the first index, the subarray of size k, let's say k is 5 in this case. Then the subarray of size k starting at this index would be 8, 3, minus 2, 4, and 5. And the sum of this would be 18, right? And since my question is to find the largest sum of a contiguous subarray, I have to consider all the options. So what's the next option that we have? This is going to be the next option. So the next window that we have is going to be start from 3. It's going to include 3, minus 2, 4, 5, minus 1, which equals to 9, right? So the way the naive approach is to, at each start index, I calculate the window sum of the next k elements after it. And by doing so, every time I get a result, I keep track of it by comparing it to the max sum, right? So if it's smaller than max sum, I don't consider it. If it's larger than the current max sum that I have, then that one is going to be the new max sum. So what's the time complexity of this approach, right? At each index, as I mentioned, we do a calculation. And what's the time complexity of that calculation? It's going to be O of k. Because at each index, I sum up the next k elements. So I have to go through each element in the next k times, which is going to be O of k, right? But since we're looking for the largest sum, we have to consider all possibilities, and we can only do that if we iterate through each single index, right? And there's going to be n start index, so the time complexity of this would be k times n. What if I tell you this is not the best approach? What if I tell you we can do way better than this? Instead of O of k times n, we can do O of n. And how do we do that? This is where sliding window comes in. Let's look at the first window, right? We have 8, 3, minus 2, 4, 5. What about the next window? It says 3, minus 2, 4, 5, and minus 1. Can you notice what's special about this? Yes, there are 3 elements in both subarray. 3, minus 2, and 4. I'm sorry, there's going to be 4 elements and 5. So the special thing here is, as we move up to the next window, the only thing that changed is 8 and 1, right? Everything else stays the same. So, or I can say that the only thing that changed when we move up, when we shift the window by 1, is that the first element of the previous array is going to get out of the array, and the new element is going to come in. The last element of the new subarray is going to come in. So instead of doing repeated work, instead of at each index I do k calculations, what if I take advantage of this nature? So as I said, the only thing that gets out is the first element of the previous array, and there's a new element comes in. So the window sum of the first one is 18, and then let's say the window sum starting at this index, we can actually do it. We can actually minus the number that just got out of the window, which is 8, and then we add the number that just got in the new window, which is minus 1, and this is going to be equal to 9. Similarly, we do it at the next index, and this will do the same. We'll get the sum of the previous window, which is 9, and then we minus by the one that just got out, 3, and then we plus the one that's new, which is 0. And it's going to be 6, right? So by doing so, by iterating through such element, by keeping a fixed size of k window, we can calculate the largest sum in one pass, O of n. and that is sliding window.